question 10, what we're dealing with is the ambiguous law of signs. All I want you to do is to figure out how many triangles will be created. Will we create 0, 1, 2 triangles? The ambiguous law of signs is a situation where we had a side-side angle. Remember, we also looked at it as a little different abbreviation, which is a pain in the backside. So these are the ones where we're not quite certain if we're going to form a triangle or not. So on the first one, in A, the first thing I want to do is recognize that the angle that they're giving us is an obtuse angle. If it's an obtuse angle, we have one of two choices. There's either no solution or there is one solution. Now, there's really no calculating that you have to do on these. All you have to do is observe whether the side that they give you is long enough to form a triangle. So the side that they give me is 13. If this 13 is smaller than the other given side, then it won't form a triangle. Think about rolling this thing down on a compass. That 13 isn't going to be long enough to reach this side over here to form a triangle. So this one's fairly easy. You can tell just at a glance of that in calculation that there will be no solution because no triangle is formed. So obtuses are fairly simple. If this side is shorter than your other given side, no solution. If this had been a 15 instead, then that 15 would have been long enough to touch down here and we would have formed one triangle. So kind of covered the basis on that one. In part B, I'm giving you an acute angle here. So if you have an acute angle, this is a little bit more dynamic. You may have no solution, you may have one solution, or you may have two solutions. And in the one solution, you may have a single right triangle, or you may just have a single obtuse triangle. I'm sorry, acute triangle. So what we're going to do, in order to find this out, especially if this 19 number that they give you is smaller than 24, you really can't make a good decision until you find the height. So I'm going to drop down the height. Remember, that height is the shortest possible distance from point C to the triangle down here. So we're going to calculate that height and see if we can even form a triangle. So to find that height, I'm going to take the sine of 48 equals the height over the hypotenuse, which is 24. So I'm looking at that triangle there that's opposite over hypotenuse. So in order to find the height, I have to take 24 times the sine of 48. Now this calculation will give me a number that I can use to compare to see if I have 0, 1, or 2 triangles. So I'm going to run this calculation, hopefully get it out of the way. Well, isn't that something? So I got 24 times the sine of 48. And that equals 17.8 to the nearest tenth. So the height is approximately 17.8. So if that height is 17.8, is that 19 going to be long enough to even form a triangle? So that's our decision. If this is 19, then it's more than long enough to create a triangle, because 19 is going to be longer than 17. So think of this as a compass and being able to swing it back and forth. So we're going to form a triangle here with 19. And if we swing it over here, it's still going to hit the triangle again because it's shorter than 24. So here's my decision making. If the height, or if the side that they give me opposite the acute angle is longer than the height but shorter than the other side they gave me, then there'll be two solutions. So this one really has two solutions because of the relationship between the side opposite the angle, the height, and the other side given. So once again, if this side is longer than the height, which it is, it's longer than 17.8, but it's shorter than 24, that means you'll have two solutions. Think about swinging it on a compass, and you'll be able to create two triangles. In the final situation, we're given another acute angle. So let's go back to our acute angle scenario. If it's an acute, we could have no solutions, 1 or 2. In order to get a good read on this, we really need to find, once again, we got to find this height. And we want to make sure, is this going to be long enough to even form a triangle? And if it is it going to be short enough to create two? So we'll run our calculations here. We want to take the sine of 55 equals our height. I didn't put that in there, but that's our height, which is opposite. Opposite over hypotenuse, which is 39. So in order to find that height, once again, we're going to take our 39 times the sine of 55 calculation and use that as a number to compare. So if that's our case, what we're going to do is take our 39 times the sine of 55 and get our value. It says the shortest path possible, so our height has to be approximately 31.9 units long in order to even form a triangle. Well, this 29 is shorter than that, so if we swing this, it'll never form a triangle. So this is a scenario where you have no solution once again. Okay, now just to cover all the bases, If I were to change this number to a 34, 34 would be longer than 31, so it would form a triangle, and it'd be shorter than 39 and create two triangles. If I make this a 40, then this would be long enough. It's long enough to form a triangle. It's longer than the height, but now it would be too long. 40 would be longer than 39, so as I sweep this around, this 40 wouldn't hit over here, so you would only have one triangle. So there's a lot of different possibilities in the angle side-side, or more officially, it's probably better to say side-side angle. Run your calculations for your height, show me what those calculations are, and then make your determinations based on reasoning beyond that.